Okay, everybody, this is a review for linear equations, stuff that we had first semester. Um, really important stuff for all the different math classes that you're going to be taking. So we put together this video and the worksheet that goes with it to kind of give you guys a little bit more practice on this, okay? So if we go back and look at this graph, I got two different lines and I'm looking at the slope of each one. So if we look at this first one here, see if I could draw an arrow. I can't. Let's do that right. Jeez. Okay, look at that one first. First off, we're going to look at how the line is going. If you read it like a book, left to right, this line is going up. So this would be called a positive slope. And from between any 2 points on the line, I can find the slope. And that's going to be determined by the rise over the run, and which is really the change in y, which is the rise, over the change in x, which is the run. Okay. Some old Greek guy came up with the letter M, or something that resembles the letter M, stands for the word slope. So finding slope, we're just, finding the change in the rise and putting it over the change in the run. So if you look at this first one up here again, in the rise, I went up 1, 2, 3, 4, and I went over 1, 2, 3, 4, 5, 6. So I get a slope of 4 over 6. And I always want to reduce that if I can. So in this case, 2 goes into both the top and the bottom, and I can reduce it down to 2/3. So that line has a slope of 2/3. I can pick any 2 points on that line to get my rise and my run. So it should be the same no matter which 2 points I pick. Okay. This one on the bottom, I just want to do show you. The slope can have a negative slope too. As you look at this line, as you read it like a book, as it goes left to right, it's going in a negative direction. So this has to have a negative slope. Once again, I can find 2 points on the line, and I can find the change in y, or the rise, and put it over the change in x, or the run. Okay, so just counting squares, I went down 3, 1, 2, 3, and I went over 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's my run. Once again, I want to see, can I reduce it? Yes, I can. 3 goes into both, so I want to be able to reduce that. Okay, so there's slope. Just looking at a graph, picking 2 points on the line, and being able to get my change. If you'll notice too, I've got a quadrant line here and a quadrant line here that intersects the line. So that's why I picked that point, and then the same thing on that one. So, that happens a lot sometimes on a line. You could pick any points as long as 3 lines are all kind of intersecting at the same point. Okay, so I did the same thing down here, the one on the bottom. All right. Okay, a couple things we have, formulas we have to have. That was just using a graph. Now, sometimes I'm not given a graph, so I have to find the slope with just points. I have to do math. So if you guys remember this formula for slope is the change in y over the change in x. So that's represented mathematically, what we just talked about. But this is when I'm given 2 points. I don't have a graph. Sure, I can go ahead and draw a graph, but this is pretty easy to do. So if I'm given 2 points, I'm going to have an x1 and a y1, and I'm going to have an x2 and a y2. I just need to take those and plug those in the right spots, and then be able to do some math. Okay, so I'll give you a quick example. I'm going to give you 2 points, 6, -2, and 3, 3, negative 3, 5. Sorry, okay? And just let's stop for just a sec. You know, I'm trying to go slow, but I'm also trying not to make this video, you know, an hour and a half long. So at any time, you know, you're taking notes on a separate piece of paper. We're not really, this isn't out of a note packet or anything. So you're really just taking notes on a separate piece of paper. Just hit pause and get yourself caught up. Don't rush. You can do this at your own pace. So I'm not trying to go fast, but I can't go really super slow either, all right? So taking these and going ahead and plugging them in, my y1 was negative 2. My y2 was 5, and I'm subtracting it. So remember this, there's a subtraction sign in the formula. You got to make sure you keep that, okay? My x1 is 6. My x2 is negative 3. So look, this is where we make mistakes because we forget what we're doing. I'm putting a negative number after the negative sign or subtraction sign in the formula. You got to make sure you go back and change those, okay? That's where we make mistakes. So negative 2 minus 5 is a negative 7. 6 plus 3 is 9. I can't reduce it, so there's my slope, okay? All right, so hopefully that's not too difficult. Make sure you go ahead and there's some practice problems that go with that. I don't think it's really hard, but you know, things like this down here, we just got to be good with our math. We have to be careful, okay? All right, the next thing that we have to have when we're dealing with slope is to be able to write the equation of a line. Different ways we could do this. This one is called slope intercept. That's because when I have this equation in the proper form, I'm going to have a slope, and I'll have a y-intercept. So remember, slope tells me what the line's doing, how much it goes up and over, and b represents the y-intercept. Where does the line, you know, hit or intercept the y-axis? Okay, remember that's the vertical line on a graph. Okay. So we got to make sure we have some of those, all right? So what we'll do with this is I'll give you a slope, and so I'll start off with the slope is equal to negative 1/4, and I'll give you a y-intercept or your b, and I'll tell you that's 2. Okay, so we'll go ahead and we'll plug. You're just plugging these in. Where does the m go? Where does the b go? I'm done. Okay, you might need to change a sign or two if the b is, you know, a negative, but really not that hard. So we're going to go ahead and plug that in. Y equals negative 1/4, because that's my slope, x plus, and that's because the b was positive 2. That's all you got to do. So that's going to tell me, hey, my line hits the y-axis at 2, and my slope is down 1 and over 4. Okay, from that point, and I could draw a line. All right. Just another practice so we could see different things. I'm going to give you a second one. I'm going to give you a slope as being positive 3. I'm going to give you a b as being negative 6. Okay, so once again, substitute those. My y equals, my slope is 3x, but now my b is a negative 6, so that it changes that plus sign into a minus sign and 6. Okay. So there's a few of those on your review that kind of go with that. Shouldn't be that hard. Okay. The next formula we have to have, or equation of a line we have to have, is a kind of a complicated one, but really important. This takes almost everything that we do into this one form, and we have to use it a lot. Okay, we have to be good at it too. This is called point slope, and sometimes they just call it point slope form, or the equation line and point slope form. So just know that I need a point, which is an x and a y, and I'm going to need a slope, which is m. Okay, my point is this y1 and x1. Okay, So that, from whatever I'm given or whatever I need a point, and I'm going to stick them there. This x and this y are basically the same y and x that we had in the point slope intercept form that we just did. Okay, so those guys stay the same. I'm going to stick things in where those ones are, and I'll also have to stick something in where that m is. Okay, there's a couple different ways to do this. So I'm going to show you the first way using this point slope form, but then I'm going to show you how to write the equation in y equals mx plus b form too. But basically all the time, I'm going to typically in the upper math that you take, you're going to start with this guy, the point slope, but you want to get it then into this form. So there's a couple of math steps you have to do that aren't really that hard, but you got to be good at it. Okay, so let me just give you an example. I'm going to give you a slope of 1/2, and I'm going to give you a point 2, -4. So I'm going to want to substitute these in to that point slope form. This is my x1, this is my y1, and obviously there's my slope. Okay, so I'm going to take those and plug them in. So y minus my y1 is -4, so we're going to have to do some work there. My slope is m, so m is 1/2, and my x1 is 2, so x minus 2. So taking stuff and substituting in there and doing some math. Okay, first thing I have to be aware of is this first step. I got to change the sign here because I'm subtracting a negative. All right, so y plus 4, I have to distribute the slope in through the quantity that follows it. So 1/2 times x is 1/2 x, and 1/2 of -2 is -1. Okay, so now what I want to do is I want to get this into y equals mx plus b. So that's this guy that we just did a little while ago. All right, so really all I got to do is subtract the 4 to the other side, and I get y equals 1/2 x minus 5. Okay, so that's using point slope, a little bit of substitution, and then 2 math steps, and basically I'm done. Another way to do that is to take the slope intercept form, and some kids like this because this is a little bit more straightforward for them, and since we're kind of using this all the time, it's nice just to kind of keep using it. My suggestion though is you have to know how to do both of these. Okay, so I'm going to take this slope intercept, I'm going to go back to the point that I took. Okay, so this 2, -4, and I'm going to take the x and y value from that, and I'm going to take the slope that I was given and plug it in. So my y value from that point was a -4, my m was 1/2, my x was 2, but I didn't have a b, so I'm just going to leave it like that. So if you'll see here, what I'm going to do is solve it for b, and then I could go take it and plug, once I solve for b, I can go take it and plug it into here. And I already have a slope, so I'll be able to go plug it back in. I'll get my equation that way. So -4 equals 1/2 of 2 is 1 plus b. I want to solve for b, so I'm going to get rid of the 1. I get my b, my slope intercept point is -5. So now I can go take it and plug it back in into the slope intercept form. My slope again was 1/2, and my b was now a -5. So I hope you understand. I got the same answer 2 different ways, and you know, there's just comfort levels in how you do that. I'm not going to tell you how to do it or which way to pick. I'm just going to say this point slope, you have to know it and you have to be able to do it. There's just going to be times where you're kind of stuck with that and you have to do it that way. Okay, but whichever way you feel good and comfortable with, you get to pick. Okay. Okay, so I showed you with a slope and a point, but sometimes, we're not very nice sometimes. So sometimes we're going to make you write the equation of a line with just 2 points. So I'm going to give you these 2 points. And, we have a bit of a process here. The first thing I have to do is to find the slope. Remember, that's, find the slope was this. And then I'm going to have to write the equation of the line. Okay, so that's kind of just doing, what we just did, using point slope or using the slope intercept form and be able to write the equation. Okay, so first off, I gotta go ahead and get my slope. So my y1 is 2, my y2 is 0, my x1 is 2, and my x2 is -6. So that's going to make me change these signs. I'm going to get 2 over 8, and I can reduce that. I get 1 over 4. Okay. Now, what I have to do now is go back and plug this into point slope or the slope intercept. I'll do both just so that you can see it. A little bit of a strategy sometimes is, when I do point slope, I only need 1 point, but I got 2 points up here. Sometimes, pick one that's easier to work with, and neither one's really the greatest to work with, but we should be able to do it. Okay, so if we go ahead and I'm gonna pick this one. I think we talk a lot all year long. Anytime you have 0 to plug in, go ahead and plug it in. So I'm gonna go y minus 0 because the 0 is a y. My slope was 1/4, and I got my x value from that point was a -6. Okay, so that's going to change the signs here. Y minus 0 is y. Okay, distribute. 1/4 of x, or 1/4 times x is 1/4 x, and 1/4 times 6 is really 6 over 4. Okay. If I ever get a fraction, I want to try to reduce it if I can. And this one I can. 2 goes into both the top and the bottom. I get 3 over 2. Okay. If I picked the other point, 2, 2, I should have got the same answer. Okay. If I do the y equals mx plus b, I'm going to pick the same point. Actually, let's do this. I'll kind of stir things up a little bit. Now I'll use the same point. I don't want to confuse you. My y was 0. My slope was 1/4. My x is -6 plus b. Okay. 0 equals 1/4 times -6 is -6 over 4 plus b. I'm going to add 6 over 4 equals b. But then, if I can reduce it, I need to. So my b equals 2 goes in top and bottom, 3 over 2. So once again, I can go back and write my equation. My slope was 1/4, and my times x, and my b is 3 over 2. And you'll notice we get the same answer either way. Okay. Okay. Couple things about lines. You see, parallel lines are going to have the same slope. So if you have 2 lines on a graph, I want to be able to see, are they parallel? Well, looking at it, it looks like these 2 are parallel. And, remember, parallel means they're never going to intersect. But I need to see if their slopes are going to be the same. Okay. So if you kind of work with me here, if I looked here, I'm trying to find a point where everything matches or intersects, and I did this, I'm going to get a slope. Okay. And then I do the same thing here. Doesn't really matter which I pick. This one I think goes all the way up to here. I should be able to get the same rise and run for each one. Okay, so that means those lines are going to be parallel. So the biggest thing about parallel lines is that they are always going to have the same slope. Okay, so if I found like this first one I did here, I went up 1, 2, 3, 4. I went over 1, 2, 3, 4, 5. Then this one has to be up 4. 1, 2, 3, 4 has to go over 5. 1, 2, 3, 4. And I'm assuming that it's there. So they both had the same slope, so the slopes are going to be equal. Okay. Perpendicular lines. Are going to be two lines on a graph where, I got one line here and I've got a second line that's actually going to intersect it now. And when they intersect, they're going to intersect at right angles. So remember, that's 90 degrees. Okay, and the way that you find this out, that the slopes are the opposite reciprocals of each other. Okay, so remember, opposite means signs. So they're going to be a positive and a negative. Reciprocals means they're going to be flipped. Okay, so let's do a couple of examples of that. When you have parallel lines, I have a slope of 2, and if I want to see it, the other one parallel to it, the other line has to have a slope of 2. So if I have given an equation like this, then the other one has to have a slope of 2. Doesn't matter what the y-intercept is, they just have to have the same slope. Okay. Now sometimes we don't give you the equations in this form. You have to do a little bit of math, get y by itself to actually see that if you're doing algebraically or moving stuff around. Okay. For perpendicular lines, we're going to look at opposite reciprocals. Sorry, going fast here. Okay, perpendicular lines, the slopes are going to be opposite reciprocal. So if I get a slope of 4, opposite means that it's going to, in this case, that was positive. My other one has to be negative, and reciprocal means I'm going to flip it. So remember, 4 over 1, that's really a 4 over 1. So when I flip it, I get 1 over 4. So I get a different sign, and I've flipped it. If I get something like this, a slope is negative 2 over 7. Well, I know the other slope has to be positive, and I'm going to flip it. Okay, so when you're asked, hey, are these slopes perpendicular? Well, they have to be different signs, and they got to be flipped. Okay, and then sometimes you have to do that yourself. We'll give you a couple of equations. They'll say, hey, are these perpendicular? You're going to have to get it, into y equals mx plus b, and then you're going to have to really look hard at the two slopes you get to see, are they opposite signs? That's the first thing I look for, and are they the flipped versions of each other? And then that's pretty easy to kind of determine. Okay. All right. Last thing with lines is being able to write things in standard form. So remember, standard form is this. And in math, we get lots of things of standard forms for lots of different things. So this is the standard form of an equation of a line. We had standard forms of parabolas. We had standard forms in dealing with exponents. We had standard forms for lots of stuff. You're going to get standard forms of circles, ellipses, other things you do in some other math classes. Okay, a couple rules that we have to have. Rule number one, that x and y need to be on the same side. And typically the same side as the left side. Rule number two, that A cannot be negative. So to fix that, we multiply everything in the equation by -1. Okay, all that does is makes the A positive, keeps the number, whatever that A is, number-wise, keeps it the same number, but I change its sign. But I have to do it to the whole equation, okay? And then the last one is there cannot be I'm sorry about that, cannot be any fractions in the equation, okay? So no fractions at all. And then to get rid of that, we're going to multiply everything by the common denominator. Okay. So let me give you one example of that we could use to kind of play with. Hopefully you got your list there, your rules that you have to have. 3 rules we have to have. I'm going to make you work all of them. First rule is that x and y have to be on the same side. You don't have to go use all those rules in that particular order that I gave you. I kind of do that. Like right here, I can see, hey, I got a fraction and I can't have fractions. I might want to get rid of the fraction right now. You can do that. You might go, hey, x and y are on the same side, so you can move x first. You can do that. Right now, this really is my A. It's positive, so I don't have to worry about that. But I bet you when I move it, something happens to it. Okay. So first, I'm just going to move the x over. So I'm gonna have to subtract 1/4 x to the other side. So that satisfies my first rule that I got x and y to the same side because they weren't. Okay. My next rule is that A can't be positive, or I'm sorry, A can't be negative. Okay, and right now it is, so it can't have it that way. Also, there can't be any fractions in it. So really, I've got two things right here that I need to get fixed, and I can do it in one step. One, I can multiply that by a negative value to make it positive. So I could multiply it by -1, and if I did that, I would get this. Basically all the signs are going to change, but I'm still stuck with, hey, I got to get rid of the fraction. Well, to get rid of the fraction, I multiply everything by the common denominator. In this case, it was that 4. Okay, so when I multiply it, remember those 4's cancel out here, so it leaves me with x. But 4 times -3 is -12y, and 4 times 6 is 24. Okay. But when we get really good at math, and I'll go back to this step here. I want to get rid of the fraction, and I got to make it positive, so I had to multiply it by a -1, and I had to multiply it by 4. Well, why don't I just multiply it by -4? Okay, so that's really doing 2 steps in one. Those 4's are going to cancel out. I get an x. -4 times 3 is -12y. -4 times -6 is +24. I got the same answer. Now, this equation satisfies every rule. X and Y are on the same side. A is positive, and there are not any fractions, okay? So there's your review. Use this to help you do that review worksheet. And make sure if you got questions, you ask it during class time, okay? Thank you.